Happy Monday, math students. This is your video for Monday, March 30th. Our learning target for the day is that I can verify if a number is rational based on its decimal equivalent. So Thursday and Friday, you learned how to convert numbers from fractions, decimals to percents, and percents to decimals to fractions. What we are doing today is we are applying that knowledge in order to verify if a number is rational. Our objective is that students will be able to convert rational numbers to their equivalent decimal or fraction form, like what we did on Friday, and determine whether the decimal repeats a pattern or terminates in zeros in order to determine equivalent ratios. This second part is what we are doing today. You will learn that if the decimal repeats a pattern or terminates, then it is rational. And if it does neither of those, it does not repeat in a pattern or terminate, then it is irrational. And then here we have our statement of inquiry, local generalizations about frequency and variability, impact, change. Our SOI brings me to our announcements. So Google Meet is now nearly mandatory on Tuesdays and Thursdays. What will be happening on Tuesdays and Thursdays is we'll briefly talk about our statement of inquiry, and then I'll be addressing commonly missed concepts and making announcements. So this is the last time I'll be doing a video for a PowerPoint where I make announcements. From here on out, all announcements and reteaches will be on those Tuesday, Thursday Google Meets, and that is to try to reduce the amount of time you spend watching these videos. The Friday Google Meet has not changed. That is still tutoring, and it is at 9. Your Mathia is due on April 5th, and that's when I said it was due back when I first assigned it a few weeks ago. But I'm not going to check this until after spring break. So what that means is I'm not giving you homework over spring break. However, if you would appreciate the extra time to complete the Mathia over spring break, if you would like an extra week, you can go ahead and take it because I won't actually be checking until afterwards. All right, you are currently here. There's going to be some stuff here. Let's get to it. So there are 3 types of decimals. The first type is a finite decimal, which you might also hear called a terminating decimal. And this is a decimal that stops. Terminate is like to stop. And it has a finite number of digits, not an infinite number of digits. So all of these are examples of finite decimals because the decimal place stops eventually. It doesn't go on forever. They can be super duper long, but as long as it stops, it's finite. This is finite because it's technically 4.0. Okay? Negative numbers can be finite as well. A repeating decimal is just what it sounds like. It's a decimal that goes on forever, but it's in a pattern. This pattern could be one number long, just a whole bunch of 3s. It could be 2 numbers long, 2, 4, 2, 4, 2, 4, 2, 4. Here it's 3 numbers long. This isn't supposed to be here. Okay, it doesn't matter. The pattern could be 20 numbers long. As long as the pattern starts repeating, it is a decimal that repeats. Okay, any sort of pattern after the decimal point. Again, it could be 1 number long pattern, it could be a 3 number long pattern, it could be a 75 number long pattern. As long as you see this pattern, that counts as a repeating decimal. As far as 6th grade goes, if you're not seeing a pattern after 5 or 6 decimals, then it's probably not repeating. Okay, so yes, it's true that the pattern could be 50 million long, but for y'all, just assume that if it doesn't repeat after 5 or 6 decimals, then it is not a repeating decimal. If it isn't a repeating decimal and it also doesn't stop, then this is not a rational number, and it can't be written as a fraction. Remember, this objective is about converting numbers between decimals, percents, and fractions, And I'm telling you right now that if the decimal is not one of these two types, then you can't write it as a fraction. And we define a rational number to be a number that can be written as a fraction. For example, pi. The decimals of pi go on forever, but there's no pattern to it. Like how here there's a pattern, 567, 567. The numbers never repeat. So pi cannot be written as a fraction. A rational number is a number that can be written as a fraction. In decimal form, a rational number is either finite or repeating. That's what we just talked about over here. Let me make this big to show you this little diagram. So here are whole numbers right here. So this is 1, 2, 3, 4, 5, 6, 7, so on and so forth, including 0. That's what's right here. Whole numbers are also integers. So if you put 3 here, you're saying that 3 is a whole number and an integer, because integers are positive and negative whole numbers. So all the positive whole numbers in 0 go here, and then all of the negative whole numbers go here. So this is 0, 1, 2, 3, 4, 5, blah, blah, blah. This is -1, -2, -3, so on and so forth. And then rational numbers are all numbers that can be written as fractions or decimals that are either repeating or terminating. What's cool about this diagram is it shows you that if a number is a whole number, then it is also an integer, and it is also a rational number. And that if a number is an integer, it's also a rational. But there are plenty of numbers that are rational that would go out here, but couldn't go in here. For example, a half. A half is rational, but it's not an integer or a whole number. If you'll notice, irrational numbers are out here all by themselves. That is because if it's an irrational number, it is not a rational number, it is not an integer, and it is not a whole number. It's out here by itself. Rational numbers can be all of those things. Irrational numbers are only irrational. Okay. I didn't put any of these in the PowerPoint because I didn't want to overwhelm you with pictures, but here's another way to look at this. So whole numbers, 17 and 0. The orange integer circle includes all of these negative numbers as well as the whole numbers. So everything inside of the orange circle, including the purple circle, are integers. And then the green circle is even bigger. Everything inside of rational numbers is a rational number. So that includes all these integers and all these whole numbers. You can think of it like a school. Rational numbers is a big school, and then integers are individual classrooms. So this is a classroom, and this classroom isn't the same thing as a school, but the classroom is inside of the school. It's part of a school. -9 is part of the rational numbers. Where's another good picture? Here's one that uses some other examples. So 8 divided by 2 might not look like a whole number because it's a fraction, but 8 divided by 2 is just 4. So that is a whole number. The square root of 9 is 3. So that's a whole number. Then you can see out here, we have some rational numbers, which is anything you can write as a fraction. And then this decimal terminates, and this decimal repeats. So these are also rational numbers. These things out here, if you typed them into a calculator, the decimal will go on forever and ever and ever. It would never repeat. Yes, we can write them like this, but we can't just write one number over another, like how we can write 7 over 8. So these are all irrational.